Assalamu alaikum wa rahmatullahi wa barakatuh. Today we will cover Unit 6 of the course M256 Software Development with Java. The unit is titled Core System Designs. In this unit we will start designing our system and decide ways in which the system will be implemented. Basically, we will, based on the use cases, take the use case, and then from that point on we start designing our interactions, deciding about our classes, methods in these classes, and make our choices of responsibilities based on that use case. We may find more than one possible design. Some of them will be better than the others, and we hope that we will be able to take the right decisions when we design our system. Basically, we will always refer to the conceptual model and structure model produced in the previous units, particularly in Unit 3. Then we will show you our method of design, our approach of design, where we start from the use case and then we use the conceptual model as our reference to design the dynamic model of the system. The unit has few aims, and relatively this unit will be longer than any other unit in the course, because it tackles very important concepts. The design of the system and design of the core system. This is very important not to be covered in detail. So the unit will introduce a simple way of dealing with communication between user interface and core system, and dividing the responsibilities between the user and the interface from one side and the core system from the other side. Analyze some use cases that do not involve changing the state of the core system, and also analyzing some other use cases that do involve changing in the state of the core system. For each use case, we will produce dynamic model that illustrates the design, and we'll show form of design that we are using. We are allocating appropriate classes, their methods, and why we built it in one way or another, hoping that we will always get the right design. We will start with the use case identified in hospital system. The use case: treat patient. Recall the use case. It says the administrator identifies the patient and the doctor. The doctor must be in the team that cares for the patient. The system records the doctor has treated the patient. So treat patient will be in more than one step. We will start from the point where we describe the use case in the system domain, and then we go on with building the dynamic models and the design of the dynamic model for this use case. That will help us identifying the functionalities that this use case needs to be performed, will help us identifying about the links between the different classes and how we can do this work without affecting the integrity of the core system objects. Remind you that the core system objects are the objects that represent the real world objects, some such as patient and doctor in this use case. The user interface we build will allow users to manipulate and change in the core system without affecting its implementation. The communicating between the user interface and the core system has different ways, but we in chapter 5 we covered and discussed a way of having some object in between the user interface and the core system. We call that object the coordinating object. and that will be based on separating the interface from the core system and protecting the integrity of the core system classes. We will have to be sure that the user interface is independent of how the core system is implemented. The user interface is replaceable without significant change or impact on the core system. Should be able to change my interface without a need to make major changes in the core system. Here is the user interface component trying to interact with the core system through the message record treatment. Here we have to decide about what record treatment will take as a parameter to be able to be performed. In one situation, we find that record treatment, if it takes the patient as a parameter, then it will be sent to the doctor. So we say that record treatment of patient 5, and we request that service from doctor 3. But if we call the record treatment method as record treatment by, then the parameter will be the doctor, as you can see here, and the client object will be patient object. So we have the choice to make the parameter the patient as the parameter and the client as doctor, or the opposite, to make the doctor and the parameter and the patient as the client object. In both cases, we are directly interacting with the core system objects, and this is something that we want and we prefer to avoid. So in both cases, as you can see, either we use record treatment by or record treatment of. We are dealing with the core system objects. This is not preferable for the many reasons we have discussed earlier. So we need to depend on the coordinating object technique to be sure that the core system classes and objects are not affected. So what we do in this particular use case and this particular system, which is the hospital system, we create a new class. We called it hospital to represent the coordinating object, and that object will receive what we call coordinating method. Coordinating message. Representing the coordinating method implemented in that particular object or class. So now record treatment is the coordinating message, and you will have for sure have a method in the hospital object on the hospital class called record treatment. So that coordinating message will take two parameters. One is a patient object, the other one is a doctor object. Now in the core system, we can call record treatment by or record treatment of, and use the same objects as a parameter or as a service provider, as we mentioned in the previous cases. But in this case, our coordinating object is hospital. Our coordinating message is record treatment that takes two parameters, patient 5 and doctor 3. And our coordinating method is the method implemented in the hospital core coordinating object to be able to perform the message received from the interface. After sending this message, record treatment of patient and doctor, to the coordinating object hospital, the coordinating object has the choice either to call record treatment by doctor and get the service from the patient, or record treatment of patient and get the service from doctor. In this diagram, you see that the coordinating object is the way in which a user interface component can interact with core system component through that particular coordinating object. In our case, it was named hospital. Now you can find that the class diagram of the hospital system include a new class called hostcourt. That's the class, and the object we used from this class was named hospital. And CORD means Hospital Coordinating Class, that can produce coordinating classes in our system. You don't see any relation between the hospital CORD class with the other classes, but at the runtime it will be able to interact with any of the classes in the hospital system. Now we learned of how to call and interact with the core system components through the interface and using the coordinating object. On the other way, we may need this coordinating object to get information from the core system classes. So in this diagram, you see that the interface is trying to get patients in ward 3, and the coordinating message is get patient of ward 3 sent to the hospital, the coordinating object. Of course, the coordinating object will find its way to retrieve all the patients in ward 3 and pass it back to the interface. As you can see, the message will return whole objects. Okay, and the whole object of patient 2, patient 4, patient 6 is passed back to the interface, and the interface will take whatever information of these objects it needed. It may take the names of these patients or the age or the address or all these informations. So the same coordinating object now is between the interface and the core system. It can pass the interaction and messages from the interface to the core system or return the result of those interactions back to the interface. And now see how we are going to design our dynamic model. We will depend on what we call scenarios. Scenario represents an example of use case involving a practical example objects. Means we will take a use case and we will take one scenario of that use case, naming some particular, for example, patient and some particular word, and then we use it to implement our idea and design. So the first thing we do, we go to the use case text. We take one particular scenario from that use case. Okay, then we go to the class diagram, take the classes involved in that particular scenario. For example, this scenario, which is a list words patient, involves two classes, word and patient. It has the relation has on, and the shown multiplicities means one word may contain many patients, 0 to more or more. Now we take one scenario, one object diagram, of that particular class diagram. One valid object diagram is to have one word and having in it 3 patients. This can be also 4 patients or 5 or 6 or 10 or no patients. All these are valid scenarios. But a helpful scenario in this situation is the one that has some patients, and in our case it has 3 patients. Word 3 has on patient 2 and 4 and patient 6. So the first step is to take the use case, take the classes involved in this use case out of the whole conceptual diagram, and in our use case we have only 2 classes, word and patient, and build a valid object diagram out of this class diagram so we can use it to complete our design. So now if we send the message get patients of word 3, according to this object diagram it will return for us patient 2, 4 and 6, and that's what we find here in this diagram. We find that hospital returned for us patient 2, 4, 6, which are the objects shown in our scenario object diagram. Now we need to design our coordinating method. Okay, in this coordinating method we have to find the name. Get patients is good one that takes the word. So we know that a word has some patients. If you want to get the patients in that word, then that word should be taken as a parameter. So I would say get patients of word 2, get patients of word 3, and get patients of word 4 all this possible. So the word name is the parameter for the method getPatient, and the getPatient method will give me a collection of patients, which means the names of the patient in that particular word given as a parameter for that method. The post condition as a result will return for me a collection of all patients objects linked to a word or the word that I am taking as a parameter. Of course, you find that the coordinating method will has three main important information or pieces of information. Information about invoking the method and the return type. In our case, it's a collection. Okay. And information about the post condition means what will be the result of calling this method and invoking this method. It will be a collection of object of type patient. It will also include what are the parameters taken, and in our case it's a general word object. It can be any object of type word implemented in our design. As you may remember, we have association and a link, as you can see it in this diagram, between the word and the patient. It's called has-on relationship, which means that word 3 has on some patient, okay, and these patients are built as a collection of patients. Can be an array or any other collection like a picture, for example. They are patient 2, 4, and 6. This link is implemented based on the the multiplicities, and in our case the collection of patients can be 0, means you have no patients in the word, or you have a number of patients in the word depending on the capacity of that word. Now, to make the patients know about the word they are in, we need to have a link or a parameter to say that patient 2 has an attribute called word, and that word will have the value 3, so as for patient 4 and 5 and 6. So now when we want to ask the patient whether they know their word, as the word attribute is implemented in those patients objects, they will be able to tell us what is the word they are in. After we have this understanding of the situation and deciding what will be the signature of the coordinating object, we will have to build the scenario that will show us how we are going to perform the use case. We call that the walkthrough, means what we are going to do, what are the steps that will help us to get the patients in our word 3. So the patient will be, first you have to decide what is given, what's available for us as objects. We have word object, which is word 3, and we need to cooperate and interact with that object to get what patients we have in that word. So we need to access the collection of patients objects linked to word 3. If you go to word 3 and ask it for the patient it will give us that I have patient 2, 4, and 6. So we'll take this information and return it back to the coordinating object that will return it back to the interface, and by this we have a collection of patient 2, patient 4, patient 6 as whole objects, and we can get whatever information we need from these objects. Here we see the steps of doing it. The interface will talk to the hospital coordinating object, give it the name of the word 3. The hospital will directly talk to the word 3 and ask it for the patient in that word. The word 3 will give us all the patients, patient 2, 4, and 6, and the coordinating object will return them back as whole objects to the user interface. After this step, we need to update the structure model. Of course, we have introduced new methods. We have introduced the method getPatients that take a word object. We have introduced the method getPatient that doesn't take any parameter. Okay, and these two parameters and links should be updated, and we should update the structure model with this new information that included some protocols and some references. Okay, if we continue doing that and take the use cases one by one, deciding about some scenario for that use case, taking the classes involved in that use case in the class diagram, building the walkthroughs, and deciding about the links, and after each one of use cases completed as a design for the dynamics of that use case, we update the structure model. By the end of this process and going through all these use cases, we will have our implementation model complete. That implementation model will be used by the programmer using some particular object-oriented programming language to implement our system. Now we'll have a look at the structural model after updating the structural model. We will see that new links have been added and new protocols have been added, and you find that we have a link which is a collection of patients that we need to use as a return data type for the method getPatients. And another method was also added to the protocol of the hospital coordinating object and the class, which is host coord. And as you can see, our structure model is now enriched with more links and more protocols. Now, a very important concept we use is what we call navigation of an association. The navigation of association will decide whether the cooperation and the interaction between two classes will go one way or two ways. In that case, if when a class A wants to communicate with the class B, then it must have a reference in class B, and in the navigation will go from A to B. If B has no reference in class B, then it will not be able to refer to class B because it has no reference in that class. If both classes have references each in the other, then we'll have a two-way association, and in that case the navigation will be both in both directions. So in this diagram we find the association between the ward and patients going from ward to patients. Means ward can talk to patient, but patient cannot talk to ward. Why? Because there is no reference in ward, in patient object of type ward. If patient object has a reference of type ward, it will can communicate back to the object of type ward. So as you can see, patients are referenced in ward. That's why you find the arrow of navigation going from ward to patient, but not the other way around. Now we can have a look at the implementation. This is not a complete implementation, like a skeleton implementation for what's going to be done. You find that the coordinating method implemented in the class host coord now is implemented, which will return patients of that ward. The same for class ward. Implementation of the method collection, getPatient is also implemented. Please note that our attribute collection is defined as being private to keep the integrity of the data within the core class word. Now, another use case will be covered just as an example of how we build our dynamic model and enrich our implementation model. We will go through another use case. This time the case is called list teams patient. This teams patient, in that use case, the administrator identifies the team. For each patient cared for by the team, the system displays the patient's name and the name of the ward that the patient is on. So in this case, you can find that a new object is now involved, which is the team object, and that's why we will go to the conceptual class diagram of the hospital system and take all the classes involved. Besides the ward and the patient classes, team class is now involved in this situation. Now what we are going to do next, as you will see soon, we will have a scenario based on this part of the class diagram, and that scenario will be our base to continue our design. It will show us some scenario where team 2 has 3 patients, 5 and 3 and 4, and 3 and 5 together in ward 2, where 4 by itself is in ward 1. We will base on this to be able to implement our use case. So now we have decided that our coordinating method in this situation and for this use case will be get patient and wards that take team 2 as a parameter. We want a result. A result will be a couples of patients and wards according to our object diagram. Patient 3 will be in ward 2, patient 5 will be in ward 2, patient 4 will be in ward 1, and that's what we get as a result from calling the method get patient and wards that takes team 2 as a parameter. Again, we repeat the same thing. We will have a design the coordinating method with the return data type and the parameters that it takes, and we will go through how this will be implemented in the core system. It's simply be implemented by the coordinating object calling the team 2 and ask it to report it is a patient, who are they and in what wards they are. Now we have to go through the building the walkthrough. The walkthrough will give us show us that we need an empty collection called result, and in that result we will have couples of teams and patients according to the scenario we built earlier. The detailed sequence diagram here shows us how team 2 is going to communicate with its patients and find out what are their wards, and then it will take the responsibility of linking each patient to its ward and return them as a collection to the hospital system, to the hospital coordinating object, and the hospital coordinating object will return them back to the interface object. This is the detailed walkthrough of how things are done. We have given the team and team 2, and then we will ask team 2 for its patient's name. It will tell us that its patient's name are 3, 4, and 5. Now its responsibility as a team to find out where are they and what wards they are, and to give me a couple of each patient and its ward name. That will be returned to the hospital coordinating object, and the hospital coordinating object will pass it back to the user interface. This will update our structure model with the new links in the class patient and the new links in the class coordinating class. We'll have one more link and one more protocol in class patient and one protocol added to the hospital coordination class object. Team class will also have more links and more protocols, as you can see and as we show in the previous sequence diagram. Now also a navigation will be also implemented between the team to the patient, because that team has to communicate to the patient, ask it for its ward. From the other side, the patient will also has to navigate to the ward, which is shown in step 3 here, and in that case we'll have a two-way navigation, as you can see here, between patient and ward, and also we'll have navigation between team and patient shown in this diagram. More examples of use cases is implemented here, and we have again to take the use case, then we study all the objects involved in this use case. We take the classes for these objects, we build a scenario object diagram, and we implement that scenario object diagram to see what messages we are sending, what feedback we are taking, and then we will build the walkthrough and implement it but after implementing the walkthrough, we'll have more information to update the structural model. We have more links added to the classes and more protocols also. More examples. So we are repeating the same thing by studying each use case and giving a scenario for that use case, building the walkthrough for the case, and implement the sequence diagram, which will enrich our final implementation model. In a very fast glance, we will have a look at the concept anthropomorphism, which is actually treating systems and software engineering as being human. So we say and put characteristics of a human to software entities, and that's very common because I assume we are using object-oriented programming, and object-oriented programming is depending totally in real world entities, and we deal with object-oriented entities as being real world entities and sometimes as human. Now we will go to the different type of coordinating methods. Before and so far, all the coordinating methods we built were methods that just take the state of the object and return some result without changing the state of the core system. In this example, we will take another use case where we change the state of the object. We don't just read whatever exists in the core system. We change the content of the core system, of course, through the coordinating object. We take the use case treat patient use case, which says the administrator identifies a patient and doctor. The doctor must be in the team that cares for the patient. The system records that the doctor has treated the patient. So when the system records that the doctor has treated the patient, means we have changed the state of the patient from not treated to be treated. Of course, we follow the same approach of design. We will consider some scenario, and this is the scenario. You find that A is the scenario before the treatment and B is the scenario after the treatment, and you find that a link between Dr. 3 and patient 5 is already there to indicate that patient 5 was treated by Dr. 3. Other than this, nothing will be changed. We will go through the same process of designing the coordinating method and building the scenario and deciding about preconditions and post conditions, building the links, okay, and then enriching the implementation model. So the same thing is also done when changing the states, the same as when we don't change the states. Now, a new thing that we may think of is about creating objects. In creating objects, we will need to build that object using its constructor. So as you can see here, you find that for every object you will have a constructor, and in Java particularly, the constructor will be called by the keyword new to create a new object. In this situation, we are building the object patient2, and as you can see from the sequence diagram, patient2 is built sometime after the system has started its interaction. So it's not, if we consider this as being the time, you find the time of creating object 8 is sometime later than the user interface and hospital objects. So they were there first, they were interacting to build the object patient 8, and that's why it came a bit lower than the other objects. So to be able to build the objects, I need to take the parameters of that object and use them to create my object. Now we talk about the responsibility for creating one-way or two-way links. As we mentioned earlier, if I want it to be a one-way link, then I will have a reference I mean, if I have, for example, classes A and B, and I want the link to be from A to B, then A will have a reference of class B and always can refer to it, where B doesn't have any class in any reference in class B, so B cannot talk to class A. If I want it to be this way, I first have to have reference in both classes, but in all cases I want to make one of the classes responsible for building that relation and for breaking that relation. Actually, we are repeating the same thing by building walkthroughs and deciding about what to do, how to create objects, and so on. In this example, we see that after creating the object, we will find out where to place that object, which is, for this case, a patient 8. Patient 8 is looking for some word, and we will have to communicate, particularly through the coordinating object, with word 1, word 2, and word 3, and see that the object is a female, so we will look for female words, and in this case will be word 1 and 3, and between 1 and 3 we will place patient 8 in the word that has less patients. Here is the complete sequence diagram for admit patient use case, where we take the information about the patient, find the right word for that patient, and when the right word is found, we will create the patient using the new keyword in Java, and then we will admit it, decide where to admit it, because in the previous stages we decide which word is the one that's suitable for this patient, then we admit it and put it under some particular team. As soon as we put it under some particular team, we will inform that team that the patient is being added to your team, and we inform the consultant doctor that that particular patient is under your responsibility from now on. After completing this sequence diagram and deciding about the many protocols and links we have here, like get type forward and get number of free beds, and admit patient to some admit the patient to some word and team, add patient to the team, and then get consultant doctor. All this will update our structure model with more links and more protocols, as you can see in these slides. This is the end of unit 6. And in this unit, please be sure that you master our way of design. I will repeat again and briefly how is it done. We first start with one use case. We take this use case, study it, and see what are the classes involved in this use case. We go to the class diagram build area in the conceptual model stage. We take only the classes that involved in that use case. We build a scenario for a communication between these classes, and we implement that scenario through a sequence diagram with the help of a cooperating object. By implementing that scenario as a sequence diagram, new methods will be created, new links will be created, and these new methods and links will be updated into our structural model. By the end of going through all the use cases and building all these sequence diagrams and updating our structure model will be ready to implement it as being the implementation model of our system. That's all for unit 6. Thank you very much. Wassalamu alaikum wa rahmatullah.